current from higher potential to lower potential. This is ICRC, and this is a drop of VCE because collector emitter junction, they are having certain resistance, so there must be certain drop. So minus VCE, that is equal to 0. That is as per KVL. And if I try to find out the IC here, it is VCC minus PCE divided by, is it? Yeah, that is by RC. Or IC is nothing but VCC by RC minus VCE by RC. Is it fine? So if we talk about load line, this is an important concept to understand. It is defined as the locus of operating point on the output characteristics of a transistor. Okay. When AC signal is applied, actually. So BJT, we require to apply AC as well as DC signals. We just want to amplify those signals. Okay. Amplified means we try to increase its energy, power of that signal. Why? Because the signals available in the nature, they are weak signals, and in order to transmit it up to a distance, we need to increase its power or energy. Okay, so that is possible with the help of BJT. So as 99% of the signals in nature, they are analog, and they are weak signals actually. Okay, so we take the help of BJT to amplify those signals, right? So this is the job of the BJT. Now we talk about the operating point. Operating point means point of a BJT, that is IC and VCE. Okay, collector current and VCE, they are going to define the operating points of a BJT, right? Operating means where it is operational, the point at which the BJT is operational. अब BJT के operations क्या क्या हैं? It can be saturation, it can be in the saturation, it can be in the active region, okay, it can be in the cutoff region, or there is a reverse mode. These are different operations. For using it as an amplifier, we'll try to operate in active region. So CE configuration of the BJT in the active region or linear region, both regions are same. That is how we can use the BJT as an amplifier. Other two configurations cannot be used as an amplifier. Okay, it is the CE which is the best amplifier among all three configurations. So I hope you understand what is the meaning of operating point now. Is it okay? So, operating point on the output characteristics of a transistor. Which transistor we're talking about? Common emitter, because it is having a very good linear region, right? If I draw the characteristics, this is something what we know. This is VC. So this is VCE and this is IC, right? This is, suppose I'm saying IV 100 microampere, 200 microampere, 300 microampere, 400 microampere. So there is variation in the IB here, and at different IB we have different ICs here. Okay, and if we talk about this circuitry, IC is nothing but VCC by RC. So IC is VCC by RC minus VCE by RC, or I am writing it minus VCE by RC plus VCC by RC. And if you remember the slope, y is equal to mx plus c. Okay, so m here is minus 1 by RC. And from this equation, if when VCE is 0, suppose equation 1, if I talk about, so IC is becoming equal to VCC by RC, and if IC is 0, VC is becoming equal to VCC. Okay, so if I draw this here, that when VCE is 0, this is the point at when VC is 0. So IC is VCC by RC, right? And when IC is 0, it is VCC. This point is VCC. So this is the entire range. Okay. So we know this is the active region, right? This is IC, this is VCE, right? We join these points. This is where VCE is 0, and this is where IC is 0. So IC is 0 from here to here, and VC is 0 at this point. Okay, so it means there is variation around this. Variation around this point. This point is called as Q point, operating point, or Q point, quiescent point basically. Q point, or this is called as DC load line. Okay, this this is the range in which uh, so if we see this, is if we go towards this side or this side, right? It is the cutoff, and this is saturation. This is active region. So for an amplifier, we'll try to use it here actually, basically. We'll try to operate this here. Am I right? इस रीजन में ऑपरेट करना चाह रहे हैं इसको. This region. In the active region, quiescent point. The ट्रांजिस्टर को इसके इर्द गिर्द ऑपरेट करवाना है हमने. To use it as an amplifier. Otherwise, it is shifting towards the saturation or it is going towards the cutoff. So when IC is 0, it is cutoff. Okay. And when VC is 0, that is saturation. So VC saturation, if you know, it is 0.2 volts. VCE active, so it can be 1, 2, 3, 4 volts, depending upon VCC. So that is the difference. So VC is, and IC 0 means cutoff. Okay. I hope you understand this.
Yes, sir.
So this point we are generally taking VCC by 2. Okay, if VCC is 12, this point is middle of that generally. So this DC load line is generally VCE or IC का relationship है when we are not applying any AC signal. When no AC signal is being applied, we can see this operating point, which is generally lying at this one. So this is the DC load line. Okay. So it is in between cutoff and saturation. That is what it means. उसके बीच का point है. Okay. हमें किस चीज in which region we have to operate the transistor? Our focus is to operate it in active region, and we know it is only the CE configuration which is best suitable for this purpose. Okay. And if we talk about AC load line, Okay, so थोड़ा सा गड़बड़ हो गया है. I'll redraw it. Now it is fine. Okay, so this is basically this point is that we know this is VC, this IC is equal to VCC by RC minus VCE by RC, or VCC by RC is equal to IC plus VCE by RC. This point. So this point is nothing but it is ICQ plus VCEQ by RAC. Reason being, because we are interested in these 2 points. Because IC and VCE, they are giving the operating points. And when we talk about AC signals, we have to vary it in this range. And this point is nothing but VCEQ. Okay. So Q is for quiescent point actually, or operating point. So this is AC load line actually, and this is DC load line. This one is DC load line, right? DC load line means no AC signal. AC load line means we don't or we are surrounded or we are operating in this region. This one. This is what we try to do. Linear region basically. This is going to define us that okay, if somebody is asking you, right, that this is a signal with us, this is a signal here, suppose, okay, which is 10 microvolts, and we want its output to be 10 volts or 5 volts as the output, right? That 5 volt means you need this with E 5 volt at least. Okay, so this point which is here where you want to operate it, it means you need a battery of VCC approximately equal to 10 volts. Okay, am I right? So if I want the VCE, that is this one. So this I need approximately 10 minus 5, 5. So ICRC is to be adjusted like this. Means it should be 5 volts, like 5 milliampere into 1K. 5 milliampere into 1 kilo ohm resistor, that is giving us 5 volt drop. So that is how. So it means we need the 5 milliampere IC actually in this case. That's why both are important. IC is important, VCE is important. So that we can you have use of these 2 points. Okay, so this is about AC or DC load line. Load means this RC is nothing but a load basically. इस circuit में what is this RC, this is a load basically. Okay, इसको RL भी लिख सकते हो आप. This is a load. इसकी जगह एलईडी हो सकता है, इसकी जगह बल्ब हो सकता है, इसकी जगह रिले हो सकती है, एनी डिवाइस, that how much drop you want across this. Okay, right? And load line means कि इस लोड को ऑपरेट करने के लिए how we try to exploit the characteristics of output characteristics of a transistor. Fine. Any questions regarding this? Hello. No questions?
No, sir.
समझ लग गया क्या मतलब है इस सारे कंसेप्ट का? सो अगर नट शेल में देखें तो मतलब प्रैक्टिकली देखें कि ये 10 वोल्ट है और यहाँ 5 मिली एम्पियर करंट है सपोज, और ये 1 किलो ओम का ट्रांजिस्टर है, तो इसके क्रॉस ड्रॉप हो जाएगा 5 वोल्ट्स। तो यहाँ कितना बचा? 5 volts, isn't it?
Yes.
Okay, and if this is 50 milliampere, 50 तो नहीं, 50 से थोड़ा ज्यादा हो जा रहा है। If this is 10 milliampere, तो कितना होगा? एक तरह से 10 वोल्ट ड्रॉप हो रहा है। तो what should be the output?
0.
0. VCE is 0. That means this is the IC saturation basically. Transistor is moving into saturation. VCE value is 0.2 in the saturation. So it depends upon IB also. Okay, because IC is nothing but beta IB. And it also depends upon beta. Beta कितना है? 100 है, और ये शायद 10 माइक्रो है, जो भी वैल्यू होगी accordingly. Right? So this is how we are operating it. So what does it mean is that we have to operate for this IC. तो IC important है and this VC both are important. IC किस चीज पे डिपेंडेंट है? IB पे. Okay, and then VC is dependent upon that also. तो दोनों का ही रोल है बेसिकली. Fine? Is it fine?
Yes, sir.
Okay, so this is about the transistors, that how the BJT is going to behave. Now we'll talk about the another topic, that is another device which is field effect transistors actually.
MOSFET.
Field effect transistors actually, there is another classification. Okay, इसको भी साथ साथ ही पढ़ लेंगे. So because BJT is a current control device, so we have two classifications. So one is unipolar and another one is this bipolars. So FETs बोलते हैं इनको, field effect transistors. Field means electric field. What is electric field? Okay, define electric field.
That has an experience of force.
Experience of force. Okay, और कोई?
सर चार्ज बॉडी के आसपास का रीजन उसको इलेक्ट्रिक फील्ड बोलते हैं, मतलब जो फील कर सके.
Okay. तो इफ आई आस्क यू कि इलेक्ट्रिक फील्ड कहाँ मिलेगा मुझे तुम्हारे घर में, है ना, मैं पहले भी की थी शायद बात में, घर में कहाँ फील्ड है तुम्हारे? इसमें
वायर्स में.
वायर्स में. ओके, और आजकल तो हाथों में भी है ना, है नहीं, बिकॉज ऑफ ड्राइनेस, इज इट?
पता नहीं सर।
डोंट नो
करंट
सर।
करंट लगता है, नहीं लगता है कई बार व्हेन यू टच मेटल और समथिंग एल्स?
नहीं सर, लगता है।
नहीं लगता?
लगता है सर, इंसान में से भी लग जाता है।
एक दूसरे से हाथ मिलाने से लग जाता है। ओके, so means charge is there, and whenever we have some charge, it must have certain energy, and it is also having a field. If that charge is static, that is electric field. If that charge is dynamic, that is which field? चार्ज स्टैटिक है तो इलेक्ट्रिक फील्ड होगा, अगर
यस सर।
चार्ज मूव कर रहा है
मैग्नेटिक।
तो मैग्नेटिक फील्ड. So when that charge is going to change with respect to time, so if you remember, they are Maxwell's equations. सुनिए,
यस सर।
है ना? That is the purpose of this charge. So as we talk about field effect transistors, so this is a current control device, BJT, and they are, because field effect transistor, so electric field depends upon voltage, so they are voltage control devices. So generally if you see, these are 3 terminal devices. इसमें एक तरह से वाटर फ्लो एनालॉगी इज यूज जनरली समझाने के लिए, है ना? So this is something, we have a tank here. Tank means we have a source of battery here, which is full of charge. So this is the tap, and this is the knob with us. So this water is there. This tap is going to turn it on or off. Okay. So when this tap is off, that means cut off region of the transistor. When this tap be turn on, okay, it is active region. And when this tap is fully on, means एक टाइम आता है ना, उसके बाद बियॉन्ड नहीं खुलता है, and the flow is becoming saturated. होता है ना, एक पॉइंट के बियॉन्ड नहीं आएगा, so that is saturation region. Okay, this is battery actually. एक तरह से ये वो सिग्नल है बेसिकली, राइट? और ये क्या है? बकेट जो होगी वो लोड है एक तरह से, ये लोड है कि आपने एक बकेट रख दी है, सो इट कैन हैंडल ओनली, इसकी कैपेसिटी के अकॉर्डिंगली हैंडल करेगा. दैट लोड कैन बी एलईडी, ओके, बल्ब, that can be a motor, that can be a resistance, that can be a speaker. Okay, ये सब लोड्स हैं वैसे. Have you seen मोटर देखी आपने? हाँ जी.
Yes, sir.
So concept of मोटर देखा है कभी? कैसे बनाते हैं डीसी मोटर? कैसे बनानी हो तो कैसे बनाओगे? बनाई कभी किसी ने?
नो।
नहीं.
नहीं सर।
No.
फिजिक्स पढ़ रहे हो आप इस बार? नहीं.
यस सर है।
क्लास 10 में पढ़ी थी सर मोटर।
किसमें पढ़ी थी?
आता था मोटर्स
है?
10th में था सर, 10th में।
बनाई किसी ने कभी?
वैसे एक्सपेरिमेंट में वैसे नहीं बनेगा।
वैसे
कभी
नहीं
नहीं
बना।
बनाई. So this is, I think, this is the working principle of motor. So we have a magnet and हाँ, मोटर लाना है पर इसे so which it is being shown actually. Okay. Just a second. So can you see this?
Yes, sir.
Yes, sir.
Yes, sir.
This is a motor, right?
Yes, sir.
This one you can see. I'll just a minute. Hold. You can see this in toys. Toys देखें पुराना कोई पड़ा है जो मोटर मोटर से चलता हो गाड़ी वगैरह कुछ भी हेलो
रिमोट वाली कार थी सर पहले।
हाँ उनमें कोई खराब प्रूफ हो कुछ भी जो भी चीज मूव करती है इट इज नॉट पॉसिबल विदाउट मोटर एक्चुअली है ना ठीक है
Yes, sir.
Yes, sir.
आपने अब एक काम करना है आज कंसेप्ट ऑफ मोटर मोटर बनानी हो तो कैसे बनाएंगे
सर 2 मैग्नेट लेके उनके बीच में कॉपर कॉपर वायर की वो कर दें कॉइलिंग।
हाँ Okay. Okay. तो इस तरह से that motor is being used. तो वन इज कि मोटर किस तरह की है, लेकिन दूसरा कंसेप्ट ये है कि उससे चीजें कैसे
सर
ऑपरेट करें.
आपकी स्क्रीन अनशेयर हो गई शायद.
हाँ हाँ. ओके, नो इश्यूज. राइट. ओके, लेट अस कम बैक टू द टॉपिक एक्चुअली, है ना. तो मोटर भी एक लोड की तरह है. तो टॉयज में कई कई जगह आप यूज होते हैं. फैन बना सकते हैं आप, है ना. सो मेनी थिंग्स व्हिच यू कैन मेक विद द हेल्प ऑफ दिस. ठीक है. तो अब हम बात करेंगे जंक्शन फील्ड इफेक्ट ट्रांजिस्टर्स की. राइट. तो दिस एनालॉजी यू माइट अंडरस्टैंड. बीजेटी हो, एफईटी हो और जेएफईटी हो, और मॉसफेट हो, इन सब में यही एनालॉजी है एक तरह से. दिस इज हाउ वी ट्राई टू ऑपरेट इट एक्चुअली. ओके. सो दिस इज something, this is, you can say, turn on the tap or off. This is the third terminal, 1 2 3, three terminals like this. Right. So if you go, I'll just show you a few images of this. So this is junction field effect transistors. Can you see it? Okay. दिख रहा है?
नो सर.
सर स्क्रीन शेयर नहीं है.
हाँ, शेयर होगी. अरे यार. I think it is shared now.
यस सर.
So this is junction field effect transistors. So instead of this, this is BJT. If you see, ऐसा था ना BJT. Okay. So इसको क्या किया हमने, जो बीच वाला है, because this is smallest one, base is the smallest. Here हमने इसको बेस की तरह यूज कर लिया, बीच वाला पोर्शन. If you see it, ये वाला पोर्शन. इसमें बेस छोटा था बिल्कुल. Okay. Right. And we are using three terminals: gate, drain and source. Right. This is what we are going to use. ये कनेक्टेड है एक तरह से. Right. Okay. I hope you understand it now. किस तरह से दिखता है ये. ठीक है. तो this is drain, this is source and this is gate. So this is a PN junction, this is also a PN junction, but this P and this P, this 1 and 2, they are shorted. यहाँ से short किए हुए हैं internally. Right. So wherever we have PN junction, we'll have a depletion region. So here we have two depletion regions. This is drain, and these are called as ohmic contacts or metal contacts also. Right? These are metal contacts. And this N is large here. That is the difference between this and this. Base छोटा है ना उसमें N. Here base we have increased actually. So this is a symmetrical device. If you see, is it? ये symmetrical है ना device? Hello?
Yes, sir.
Yes, sir.
Okay. Right? This is junction field effect transistor. So FET is a three-terminal device with one terminal capable of controlling the current. So gate is to control the currents, right? And there we have drain and source also here. So source is source for charge carriers. Source for charge carriers. And drain is, so basically अगर analogy की बात करें, if I talk about this, source है ये. This is drain and this is gate. So gate is to control the current flow of the charge carriers. That is going to control the current. Source is source of charge carriers because this tank is full of charge carriers, and drain is where charge carriers are drained. Okay, so this is drain. This is bucket likes. That's why these three terminals, they are here. Okay, so we'll start studying about its working in the next class. Any questions from today's class? Andy? Or any previous class, any of questions which you would like to share with me, ask from me? नहीं? ठीक है?
Okay, sir.
Okay.
Yes, sir.
तो मोटर का कंसेप्ट देखना आप लोग, ठीक है। शो सम वो वीडियो नहीं मिल रहा, बहुत अच्छा वीडियो था। सो आई हैव वन सिंपल वीडियो, आई विल ट्राई टू फाइंड इट आउट एक्चुअली, है ना। मैं आपको शेयर करूंगा, आप देखना फिर, है ना। हाउ टू डिजाइन डीसी मोटर, बड़ा सिंपल सा रहता है, तो आप लोग कर भी सकते हैं उस चीज को। somebody is interested in this, ओके।
We will do.
ओके।
हाँ जी, क्या बोल रहे हो?
सर ट्राई करेंगे बनाने को।
हाँ हाँ, ठीक, बिल्कुल, बड़ा आसान है, कोई बड़ा मुश्किल नहीं है। द ओनली थिंग इज यू हैव टू गेट स्टार्टेड एक्चुअली। ओके, ठीक है,
यस सर।
चलो ठीक है फिर, थैंक्स फॉर बीइंग विद मी एंड हैव अ नाइस डे, बाय फॉर नाउ,
You too, sir. You too.
थैंक यू,
Thank you, sir.
बाय।
Thank you, sir.
Sir, can you give the names, sir, of the